All right, I'm back. We're on page 4 of Calc AB Notes 6. We're talking about implicit differentiation, all the sorts of things you can do with it. Let's see what this page has for us. So, because arithmetic is easier than algebra, that is a fact. I would rather do, actually, I don't know if that's true. I might prefer to do algebra over arithmetic because like terms, like arithmetic, everything is a like term, so you can collect everything. Algebra, it's a little dicier. So sometimes I prefer algebra, but whatever. If I'm asked to find the slope at a specific point, I usually, emphasis on the usually, don't waste my time solving for dy dx. I just plug in, and then I solve for dy dx, which will be the only variable that's left. I usually do that. Sometimes there's this weird-ish thing that happens. It's very weird when you don't know why it's happening. If after the substitution, all of your dy dx's are gone, that's a problem. So then what I do, I will go back and I'll solve for dy dx, and usually you'll see that the slope is just undefined at that point, meaning you're vertical at that point, which happens a lot on implicitly defined functions, curves, relations. So let's do a problem and see what happens. I don't know. I mean, if I had to guess, I would say that's going to happen at some point, but who knows? Here we go. I see a lot of product rule. So I'm going to skip that first step, and it's first derivative of the second plus second derivative of the first 2y, but y is a function of x, so chain rule gives me dy dx plus, all right, it's first derivative of the second plus second derivative of the first, so 3y squared, y is a function of x, so we get another dy dx. It's a really long derivative. Minus 10 plus dy dx. And then this, if you mess up here, you're going to really regret it. The derivative of 5 is 0. Okay, so now what are we going to do? I'm going to substitute 2, 1. So everywhere that I see an x, I'll make it 2. Everywhere I see a y, I'll make it 1. So how do I denote that? I'm going to say at 2, 1, colon. Okay, so y is equal to 1, x is equal, so y is equal to 1 is a really nice, generous thing that was done for us. So x is equal to 2, so I'll get 3 times 4 is 12, plus 8 times 2 is 16. It's like a really sad looking dy dx up above there. Plus 8 times 4 is 32, plus 4, nope, 2 to the 4th is 16 times 3 is 48 dy dx's, minus 10 plus another dy dx is equal to 0. Okay, so what happened here is that this gross algebraic thing, which I could have solved for dy dx, but like, became this like relatively nice algebraic thing, right? We got 12 plus 32 minus 10, which is really just 32 plus 2, so 34, plus 48 plus 16 is 64, and another is 65. dy dx equals 0. So dy dx at 2, 1 is negative 34 over 65. And that wasn't that bad, right? If we had first solved for dy dx, it would have been a little worse. Let's see what the calculator tells us is happening here. So I want to do implicit differentiation, y squared x cubed plus y cubed x to the 4th minus 10x plus y equals 5x comma y. And so that's what we would have gotten. So such that x equals 2, such that y equals 1, negative 34 over 65. So we got it. And I think this is a very useful thing to do, where you avoid like the algebraic manipulation when you can, because you're just more likely to make a mistake there than you are arithmetically with arithmetic. So let's try this one. I'm going to hopefully do the same thing. So the derivative of y to the 4th, 4y cubed, but y is a function of x, so dy dx, chain rule, equals, so 2y, chain rule, dy dx, minus 2x. Okay, so I don't even know if I want to sub in here. Like I have to, so obviously I'm going to, but I don't think I want to. So at -1/2 root 2 over 2. This feels like a polar problem, or like I'm supposed to be doing this in polar coordinates or something, because that almost feels like a unit circle point, but it's all wrong, right? It's -1/2 root 3 over 2. It's just like famous ratios that are doing me no good, frankly. All right, so I'm going to have 4. Now, y cubed, I'm going to think of y, just trying to make my life a little easier. It's not going to really be that. I'm going to think of this as 1 over root 2. Now, why would I do that? I would do that because when I cube that, I get 1 over 2 times the square root of 2, right? Because I get 2 to the 3 halves. 2 to the 3 halves is 2 to the 2 halves times 2 to the 1 half, which is 2 times root 2. So we get that, basically, is what I'm saying. Dy dx equals, okay, so 2, oh my god, I'm going to think of it as root 2 over 2 this time. I'm bouncing all over the place here, but I think it's going to pay off. Dx minus 2 times -1/2. Gross. All right, so this gives me 2 dy dx equals root 2 dy dx. 2? No, it doesn't. It gives me 2. Ooh, messed up. 2. I get 2 over root 2. 2 over root, so 2 over root 2. But if you rationalize, gives you actually just root 2. So I get root 2 dy dx equals, root 2 dy dx, and then plus 1. So what does this give me? It gives me 0 equals 1. That's not true. There's no dy dx's. So why did this happen? So to figure out what happened, we have to go back to here, and we're going to actually solve for dy dx and see if we can figure out what's going on. So here, I'm going to get 4y cubed minus 2y times dy dx is equal to -2x. So dy dx, it just literally keeps getting darker outside. I don't know what's going on. It's like 2 o'clock in the afternoon, but every second it's a little bit darker. I think perhaps we're in for a storm. Minus 2y. Okay, so if y equals what y equaled, right? Radical 2 over 2. 4y cubed minus 2y equals 0. So that means, therefore, the slope is undefined. So what does that mean? So we're trying to write the equation of the line tangent. What kind of line has a slope that is undefined? It's x equals something, right? But then what does x equal? X equals -1/2. I don't know why that looks that way when I did that. I must have picked up the stylus. X equals -1/2. So that actually is our line. Therefore, the tangent line is x equals -1/2. And that's our answer. So I'm going to highlight that. I mean, really all of it is our answer. But when you get an undefined slope, that means that the slope of the tangent line is undefined. What has an undefined slope? A vertical line. I think in the next video, I might actually turn on a lamp or something. This is crazy dark. Should I do this problem now? I don't know how long I've been doing this, so I'm just going to go for it. Hopefully this doesn't become like a giant disaster, which it might. Let's see. So first, we're looking for the second derivative, but you got to start with the first. And I don't even know what I'm doing. Okay, here we go. Product rule. First, derivative of the second plus second derivative of the first. Okay, product rule. So I'm going to treat the first function as negative y squared. So first derivative of the second plus second, the derivative of negative y squared is negative 2y dy dx, and then that'll equal 0. Okay, now I got to find, I'm going to solve this for dy dx because I think it makes your life easier. So how to do that? I'm going to do that in fewer steps than usual. dy dx is, so I'm going to add y squared. So it's y squared. I'm going to subtract 2xy. So where did that stuff come from? That came from, I added y squared because of this, and then I subtracted 2xy because of this. And now I'm going to divide by, what are the coefficients of dy dx? It's x squared minus 2xy. That's really interesting. There's like symmetry or something in the, I love how dark this is. This is crazy. There's like symmetry in our derivative. I don't know that it means anything, but so now we need the second derivative. So we're gonna find the derivative of this thing with respect to x. It's gonna be kind of gross. So the second derivative, okay, quotient, so quotient rule, bottom. Derivative of the top, which is just gonna be awful. So it's 2y dy dx minus, oh my God. So it's negative 2x times y. So it's really a product rule. It's first derivative of the second plus second derivative of the first. Okay, that was bottom times derivative of the top. And now minus top 2xy derivative of the bottom, which is 2x. And then it's product rule again. So it's first derivative of the second. Am I even going to fit this? Plus second, which is, oh, never lose your train of thought while you're doing a quotient rule problem. So it's bottom derivative of the top minus top derivative of the bottom. Okay, and then I'm in the middle of a product rule. First derivative of the second, second derivative of the first. So plus y negative 2. I mean, I hope I didn't mess that up, but that could have cost me. All over the bottom, whew, squared. Okay. So let's see, at the point, so our point is negative 2, 2. So it's like this. So I'm going to find dy dx there. So I can do like a three-way substitution. Dy dx at, so let's say, at, what are we at? Negative 2, 2? Too ambitious. Should have done this in a separate video. Whatever. I get 4. 4 minus, oh man, 4 plus 8, I guess. 2 times 2 times 2 is definitely 8, and it's plus. Over 4, and then plus 8. Okay, that's nice. dy dx is just 1, which is nice because it makes everything a little easier. Okay, so let's do this. Here we go. Second derivative at, whoa, the rain has shown up. X squared minus 2xy. I feel like this is going to show up a lot. I got 12 for that. So that was 12. And then 2 times y is 4 times 1, plus 4 times 1, minus 4, okay, minus, I don't know, do I even want to check this? All right, so y squared minus 2, so this was 8, no, this was 12. And then 2 times x is negative 4, I think, yeah, plus 4. It's good, that's 0. And then minus 4 again. Holy cow. All over. This thing, I think, was 12 and then squared. Whew. All right, so what are we dealing with here? We got 4. You got, well, basically you have 48 minus 12 times negative 4. Okay, over 12 squared. So really you have 12 and then times 8 over 12 squared, which is 8 over 12 Divide everything you see by 4. Could it really be just 2/3? I don't know. I'm gonna check it. This is probably a long video. I apologize. I was too ambitious. You know, I was just like, oh, we're killing it. All right, so let's do imp diff of x squared y minus y squared x equals 16. I don't even remember that being the problem. So like, I hope this went well. And then I'm gonna put a 2 because I want the second derivative. Okay, such that x equals -2, and then such that y equals +2. 2/3, unbelievable. We got it. All right, so that was a journey. And I sort of regret doing that problem in this particular video, but we were gonna do it eventually anyway, so like, whatever. But anyway, this is it. We just did so much work. I don't even know. If you were with me the entire video, like really, honestly, very good for you. So let's just cut it here. I'll be back in the next video. We'll do more, maybe take a break. See you soon. And I hope you are finding these really helpful because they're a lot of work, but I mean, I'm not enjoying it. I'm kind of enjoying making them. Anyway, see you soon.